Hello guys, in this video we are talking about broadcast join AQE means adaptive query execution in Apache Spark. So let's go about interview question and answers. First question is, what is AQE and how does it different from Catalyst Optimizer? The Catalyst Optimizer built in query execution plan before job run using table statistics that may be stay eliminate. Means table statistics means row count and table size. Once the plan is set, it does not change. AQE means adaptive query execution re-optimize the plan at runtime between shuffle stage. Using actual execution statistics, after each shuffle stage completes, AQE observe real partition size and row count, then may college empty partitions, convert short merge join to broadcast join and split skew partition into smaller ones. In short, Catalyst is a static optimizer and AQE is a dynamic optimizer. Next question. Explain main three optimization AQE provides. AQE provides three runtime optimization. First, dynamic shuffle operation partition coalescing. If the default 200 shuffle partition produce many empty or tiny partition, example, because your data only has 50 distinct key after group by, AQE merge them down to appropriate number, reducing scheduler overhead. Means basically the 200 शफल आहेत आणि त्यात फक्त 15 यूज होतात आणि वरले 185 एम टी असतील तर ते कोलेजचा वापर करून पार्टिशन कमी करतं आणि फक्त जे यूज होणार आहे तेवढंच पार्टिशन देतं. यू हॅव टू सेट मिनिमम पार्टिशन ॲज 1 फॉर दिस. ओके. नेक्स्ट इज डायनॅमिक जॉइन स्ट्रॅटेजी स्विचिंग. If Catalyst plan short merge join but AQE discover at runtime that one side is smaller than other and it is one table is small and one table is large, then for smaller table we have to use broadcast threshold. It converts join to broadcast join, avoiding expensive shuffle. Basically in that AQE dynamically analyze करते. First short merge join घेते, but when AQE discover that at runtime one side is smaller than then we have to broadcast the smaller table. Next is dynamic skew join handling. AQE detects partitions that are sufficiently larger than median and automatically split them into smaller sub partitions, distributing the skew work across more tasks. Again, AQE detect partitions that are significantly larger than median by configuring factor or absolute size threshold and automatically split them into smaller sub partitions, distributing the skew work across more tasks. Explain short merge join step by step. Short merge join has three phases: shuffle, sort, and merge. In short merge join, both datasets are re-partitioned using hash partition. Formula is hash of join key percentage number of partitions. The guarantee that rows with the same join key land on the same executor. This phase involve network data transfer of both entire dataset. It is the most expensive step. In sort phase, each executor sort received data from both tables by the join key. This is required for different efficient merge step. Next, in the merge phase, two sorted pointers walk through both sorted lists simultaneously. When both pointers point the matching key, the rows are combined and eliminated. The merge is O of n once sorting is completed. The key variant is all rows with the same key go to the same executor. If one key is extremely frequent, means data skew, one executor become the bottleneck. How does broadcast join work and why it is immune to data skew? In broadcast join, the entire small table is serialized and sent to every executor that holds the partition of the large table. The driver collects the small table, then push copy to every executor memory. Each executor performs local hash join between each chunk of the large table and its local copy of the small table. No shuffling of the large table occurs. It is immune to skew because the larger table is never repartitioned. In short merge join, repartitioning by skew key is what cause hotspots. All row of the skew key piles into one executor. In broadcast join, the large table stay in its existing partition regardless of key distribution. Each executor join whatever row is it already has against the complete copy of the small table. Next question. When would you choose broadcast join over the short merge join? Cause short broadcast join when the small table fit comfortably in executor memory, typically under the auto threshold, auto broadcast join threshold. Default is 10 MB. Through you can raise it specifically. Use broadcast join when the small table is lookup table, for example, product catalog, country code, customer segment, etc. The join key is skew in the last table or shuffle overhead dominant job type. Avoid broadcast join when small table is large, means broadcasting 10 GB table is out of memory executor. You are joining multiple large table where no side can be broadcast or network bandwidth to bottleneck. Broadcasting across slow networks is still expensive. A partial practical rule: if the smaller side of the joint is under 100 MB and executive memory is sufficient, broadcast joint is almost always is right choice. Next question: how does AQE skew joint handling differ from manual sorting? Both solve data skew joint but differently. AQE detects skew at runtime by measuring actual partition size after the skew. If partition exceed means skew partition factor into medium size and absolute skew partition threshold in bytes, AQE split that partition into sub-partitions and join each sub-partition against the duplicate of the matching data on the other side. Manual sorting work pre-shuffle by appending random integer to the join key before shuffle happens, forcing the skew key rows to distribute across multiple partitions from the start. Different key difference. AQE requires zero code change. Sorting requires code modification. AQE only handle join. Sorting also handle aggregation. For extreme skew, one key is equal to 99% of data. AQE may still produce some imbalance. Sorting gives precise control. AQE split approach duplicates some of the non-skew side of data. Sorting exploit increases the small tables. In practice, AQE is first line of defense. Manual sorting is for cases AQE cannot handle full handle. Next question: what is auto broadcast join threshold and how did you tune it? So spark.sql.auto broadcast join threshold is minimize maximum size in bytes of the table that Spark will automatically broadcast in the join. The default is 10 MB, means 1,04,85,760 bytes. Tables smaller than the threshold are broadcasted without any hint from the developer. To increase it, spark.config.set in bracket spark.sql.auto broadcast threshold join threshold, comma in double quote 100 MB we can give. To disable auto broadcast, we can give -1 instead of 10 MB. Tune it based on the typical size of your dimension or lookup size table. Available executive memory in bracket broadcast table must fit in the memory on the every executor. Bracket complete. And network bandwidth means larger broadcast is equal to more network transfer. A common production setting is 50 to 100 MB if executor having efficient memory like 8 GB plus. How does broadcast join behave in multiple joins? means 4 5 tables. When joining multiple tables, each binary join is evaluated independently for broadcast eligibility. If table A 10 MB join table B 500 GB, then the result the result joins table C, that is 8 MB. Spark can broadcast A in the first join and broadcast C in second join. The important constraint con- constraint is that the result of join is generally too large to broadcast. Again, the important constraint is that result of join is generally too large to broadcast. So in chain of the join, only original dimension table, which typical small, can broadcast. No intermediate result. Spark Catalyst Optimizer or AQE runtime evaluate each join independently to explicit control which table are broadcast in multi-join query. Next question: What are risk? What are risks of setting at broadcast join too high? If threshold threshold is set too high or large table get broadcast, then first out of memory executor. Every executor must hold broadcast table in memory simultaneously. A 2 GB broadcast table on the 10 executor cluster is equal to 50 to 20 GB of memory consumed just for broadcast variable, often causing out of memory error. Next, driver bottleneck. The driver collects small table and serialize it for broadcast. A large table can overwhelm memory driver. Network such garbage collection pressure. Large broadcast variable in JVM heap memory heap increases GC garbage collection pressure, causing task pauses. The safe approach: keep the threshold conservative, means 10 to 100 MB, and use explicit f dot broadcast it only when you have verified the table's actual size is small. This is about AQE and broadcast join.